So hi, welcome to the YouTube channel of Independent Science News. I am molecular biologist Jonathan Latham, and this week I thought we would do a book review, and the book I want to show you is called Pandora's Poison. I only have the hardback version of it. It was written in 2000 by Joe Thornton and is with MIT Press. And the reason for showing you this book is, it is a really nice example of how to learn a lot of information about biology and science in a very short space of time. It's a very nicely written book, it's easy to read, and it has a point to it. It has a very important point. So the purpose of this book was that Joe Thornton was working for Greenpeace. At the time he actually wrote this book, he was also a graduate student. But he was originally working for Greenpeace, and Greenpeace wanted a new strategy for environmental campaigning. They wanted to get away from the piecemeal, one chemical at a time approach, which essentially they saw as failing. So the piecemeal approach had basically caused them to focus on one single pesticide or one single harmful, quote-unquote, bad active chemical at a time, but they fully well knew that, with 75,000 chemicals in commercial circulation, quite a large number of them appearing in, being produced in large quantities, that you're never going to save the planet from a toxicological meltdown if all these chemicals are appearing on the market, not being properly tested. There needs to be some kind of ecological, environmental movement response that is equal to the task of assessing the significance of these 75,000 chemicals. So they decided to take, in a way, a scientific approach, right? And focus on one class of chemicals, which are very commonly manufactured. And these are chlorinated compounds. So carbon compounds with chlorine groups added to them. So more than one chlorine group in many cases. And basically see whether there was not a case for regulating those compounds as a group and removing them from the market. And so this book, basically was written to make that case. And it was reviewed in Nature magazine, which is how I came across it. And it was an instrumental book in my education because it went into many of the problems of conventional toxicological testing. The one chemical at a time approach, is compromised by the fact that we're all exposed to mixtures. That's commonly made point. But it's also, brought attention to the fact that single chemicals at a time they're tested. They're basically tested one time, but it would take forever to test that number of chemicals. That the toxicological tests are fundamentally inadequate in many ways. Animals are not good representatives of the human population, and there's also you need to collect so much data about an individual chemical to decide whether or not it should be regulated, banned, or approved, that essentially the process was taking forever. And as we saw in the review that I did for permethrin, you can see how many chemical tests are required, the sort of, the lengthy endeavor it goes through to become approved, which, in the case of permethrin was largely fraudulent. But nevertheless, it still is a very time-consuming process. So the idea of this strategy was to, was to ask the question, why can't we not group, say 10,000 of these chemicals and say that by and large all of them should be basically removed from the market? And so Greenpeace, because there are other, before I go too much further, there are other strategies, right? There are, for example, you could transition your society to organic agriculture and say that chemicals used for certain processes, like on food, like no chemicals should be used on food, for example. It would be another campaigning strategy. Or to have a campaigning strategy where chemicals are not used, for example, around schools, and in that way protect students. So these would be alternative strategic approaches to campaigning to reduce the overall exposure of the population to toxic chemicals that didn't rely on opposing one single chemical at a time. And by the way, the issue of one exposing the population to one chemical at a time also is a campaigning difficulty, because it presumes that the members of the public are intimately familiar with the toxicological details of one single chemical, like Roundup, for example, the herbicide Roundup, which is made mostly by Monsanto. If you want to campaign against Roundup, then obviously, your neighbors and your friends are going to ask, why are you opposing Roundup? Well, I'm opposing Roundup because it has A, B, and C black marks against it, and the neurotoxin, and they're going to ask you all sorts of questions like, how do you know it's a neurotoxin? Basically, it requires that members of the public have an inordinate and unreasonable amount of knowledge about individual chemicals, which makes it difficult for those campaigns to ever really to catch fire. And so this is another part of Greenpeace's thinking. So what they did is they decided to focus on chlorinated compounds. They focused on chlorinated compounds because essentially chlorinated compounds are hydrocarbons in which chlorines have been substituted for hydrogen groups. And these compounds in which have done this, they often are quite closely related in structure and function to naturally occurring compounds. But chlorine is basically something that's pretty much only added by chemical companies, right? If you go to your garden and you dig in the soil, there are no chlorinated compounds in there unless they're environmental contaminants. So these compounds they're specific to industrial chemistry. They are chlorinated compounds. Compared with their direct equivalent non-chlorinated compounds, are overwhelmingly more likely to be toxicologically active. They are also more likely statistically, and all these answers are statistically, they're more likely to be longer lived in the environment, right? They don't break down so well because organisms don't have the enzymes to break them down because they're unfamiliar. They're also more likely to be fat soluble. What that means in practice is that they will accumulate in the food chain. Now, if you only add one chlorinated molecule to a complex hydrocarbon, the incremental increase in toxicity, in fat solubility, in long-livedness will be relatively small. But if you add multiple, which is the case for many compounds, and you add 2, 3, 4, 5 chlorinated compounds, then these factors really add up. So you end up with compounds that are often way more toxic, way more longer lived, and way more fat soluble, to the extent of, for example, dioxins, which essentially don't, apart from in the presence of sunlight, do not break down in the environment at all. And so essentially, unless those compounds become buried at the bottom of the sea, they will basically, they'll live forever, and they will accumulate in the food chain, and cause very, very severe environmental problems, even if they're present initially in very low concentrations. And we have very many of these compounds in circulation. So, including pharmaceuticals, pesticides, food additives, all kinds of compounds are chlorinated hydrocarbons. The other interesting, so there are other chlorinated, non-chlorinated, there are other halogens. Right? Chlorine is a member of the chemical group halogen. There are other halogens, bromine, iodine, fluorine, which also have many of these properties too. So fluorinated hydrocarbons, for example, are the waxes that people are putting on skis, or the Teflon that people are using. These compounds, they are even more fat soluble and appear to be even more toxic than chlorinated hydrocarbons, and for much the same reasons. So much of the same arguments can be made, and that's why we have such ecological issues with brominated flame retardants, for example. But just going back to chlorines, what this book does is it did an analysis of all the uses of chlorinated compounds in our society and asked the question, actually, do we really need them, right? Do we really need to be making compounds that are long-lived, more toxic, more fat-soluble, and generally classified as highly undesirable environmental contaminants? And the answer was no, that for the most part, there are perfectly ready substitutes that could be used and that a sensible society would be using. And so this book became the justification for an incredibly rational ecological strategy. And because of this strategy, which Greenpeace started to implement in the early 2000s, and they started to implement it, and what happened was they got incredible pushback from the chemical industry, right? Because the chemical industry is perfectly happy combating environmental organizations that challenge them on one single chemical at a time, because that strategy is basically bound to fail. And what that strategy also does is it kind of implies that the regulatory system is perfectly functional, but there are merely bad actors, chemicals that exist in the environment, and if we got rid of those, everything would be fine. And nothing could be further from the truth. But that's what the bad actor strategy, the traditional environmental strategy, consisted of. And so this is the strategy that Greenpeace basically wanted to move away from. And so they wrote this book. Joe Thornton basically wrote this book to justify that strategy. And the pushback that Greenpeace got from the chemical companies, I would argue, was quite important in their fundamentally discontinuing that strategy. But in my opinion, it was actually the totally right strategy. If we're going to remove environmental contaminants from our environment, this is exactly the kind of thing that we need to do. But at the same process, that will require fundamental disruption of the business model of the chemical industry, right? Because if you can't envisage, it's very difficult to envisage. Let me put it that way. That the chemical company can pump out so many environmental toxins, and for that production process to be compatible with a environmentally sustainable civilization, right? If you're going to equate technology with civilization and chemical use with civilization, you need to work out how those chemicals, those technologies are going to be made without chlorinated compounds. And what this book showed is that it's perfectly possible to do that. It's entirely unnecessary to pollute the environment with all these chemicals, because we can produce chemicals, for example, that biodegrade, right? There's no reason whatsoever why we can't do that. And so many of the critical uses for these chemicals can be replaced by versions that biodegrade and therefore do not imperil future generations and our children or break down themselves into toxic compounds. So thanks very much for listening to this week's edition of the Independent Science News YouTube channel, and have a good week. Thank you. Bye.